Greetings and welcome to more graphing quadratic equations as promised. Hopefully this video will help you in your venture to graph quadratics correctly. Let's review vertex form. Vertex form is y equals 1/2 times the quantity x plus 1 squared plus 2. The reason vertex form is easy to graph is because the vertex is easily acquired by just looking at the equation. I take the opposite of what's on the inside and then the same as what's on the outside. So the vertex of this parabola is -1, 2. So if I plot that, I go to x is equal to -1, 2. If I know that the vertex is -1, 2, then I know my axis of symmetry is x equals -1. So for those of you that need to visually see it, let me put that in my graph here. What else do I know? Well, I should know that my domain is all real numbers because that is the domain of any quadratic. I know that this opens up. And I know that it opens up because if I look at y equals 1/2 the quantity x plus 1 squared plus 2, the 1/2 is positive. In this case, I also have a vertical shrink by a factor of 1/2. So now I have to find some more information, and let's find it first by finding my y-intercepts. So to find my y-intercepts, I'm going to let y equal 0. Then I'm going to subtract 2 from both sides. Then I'm going to multiply both sides by 2. And when I take a square root, look at what happens. I end up taking the square root of a -4. Therefore, I know that this graph does not have any real number x-intercepts. Now, another way that you can figure this out is if you know that this graph is going up and you notice that the vertex is above the x-axis, then it could never touch the x-axis. So what do I do in the meantime? Well, let's find our y-intercepts. I find the y-intercepts by letting x equal 0. So this is just arithmetic. 1/2 times 0 plus 1 squared plus 2 is 1/2 times 1 plus 2. And so what I get is y is equal to 2.5. So my y-intercept is at 0, 2.5. So let's go ahead and plot that. And remember that I can also plot on the other side. It's mirror image. So from here, honestly, you just have to pick 2 more points in order to get your 5 points. So what I would do is I would let x be 1. If I let x be 1, I want to take 0.5 times 1 plus 1 squared plus 2. And that gives me an output of 4. So I know that the point 1, 4 is also on the graph. And then I can reflect it on the other side. And now I get a nice pretty graph of my parabola. This means my range is going to be all of the values that are 2 and bigger. So y is greater than or equal to 2. And now I know that I have a minimum at the vertex -1, 2. And let's review intercept form. We like intercept form because getting our intercepts is easy. If I just look at y equals -2 times x minus 1 times x minus 5, it's in factored form. So using the zero product property, I can conclude that 1, 0 and 5, 0 are my x-intercepts. So let's go ahead and plot those points. All right. Now, what else do I know? I do know that my domain is all real numbers. Because the number in front of my factored form is -2, the negative tells me that it opens down, and then the 2 tells me that I have a vertical stretch by a factor of 2. Now I need to find the remaining information. Well, we know that the axis of symmetry should fall right in between those x-intercepts. So if I use fingers, I know that x equals 3 should be the axis of symmetry. Mathematically, I could take 1 plus 5 divided by 2, and that would equal 3. So that is one way to find my axis of symmetry. Now, if I know that the axis of symmetry is x equals 3 and the vertex has to lie on the vertex, I know that the x-coordinate of my vertex is 3. So I have to do a little bit of work. Okay, I know that this is my equation, and so I have to substitute 3 in for x. So I'm going to take -2 times 3 minus 1 times 3 minus 5, which yields -2 times 2 times -2, and I get 8. So my vertex is 3, 8, and let's plot that. And that should make sense. The vertex had to be above the x-axis because we know that this is a downward-facing parabola. Next, let's find the y-intercept. And I get the y-intercept by substituting in 0 for x. So I get negative 2 times 0 minus 1 times 0 minus 5, which is negative 2 times negative 1 times negative 5, which yields negative 10. So if I plot 0, negative 10, I can also plot its mirror image on the other side of the axis of symmetry. And this is not going to be the best because I'm doing this on the smartboard and it's kind of hard to do with just a laptop. Oh, that was terrible. Let's try that again. All right, here we go. All right, so you're getting the drift. That was pretty bad. But like I said, try to do that on a laptop. I need a mouse or a smartboard. So there's the picture of a purely kind of drawn a parabola, but it's the best we can do underneath the circumstances. So my y-intercept is 0, negative 10. My range is going to be all of the values that are less than or equal to 8. And I do have a maximum value at 3, 8. And welcome to standard form. This is the problem we started in class, the bell rang, and we weren't able to finish. The issue with standard form is that you aren't given the vertex and you aren't given the x-intercepts, and you have to work to do both. But always look to see if you can put it into a different form easily. Y equals negative x squared plus 4x minus 3 does factor, and we can put it into intercept form. So I have y equals negative x plus 3 times x minus 1. And what is nice about this is when I use the zero product property and set each of those equal to 0, I have negative x plus 3 equals 0, and then x equals 1 is solved. So I know that x equals 1 is an x-intercept. On the other one, just be careful with your signs. You have to subtract 3 from both sides and then divide by negative 1. So I also get that x is equal to 3. So my x-intercepts are 3 and 1. I will let you know that your y-intercepts are pretty easy. You should be able to just look at the standard form, y equals negative x squared plus 4x minus 3. And when you substitute in 0 for x, you get negative 0 squared plus 4 times 0 minus 3. So it's just the constant negative 3. So my y-intercept is 0, negative 3. And we want to reflect that over my axis of symmetry. Well, my axis of symmetry has to fall right smack in between my x-intercepts. So if you use fingers and count and use the graph, you'll see that the axis of symmetry is x is equal to 2. For those of you that need some arithmetic, I can take an average of the x-intercepts. So 3 plus 1 divided by 2 is 4 over 2, which is 2. And then you can plug 2 back into either the original standard form or the factored form. I use the factored form. Negative 2 plus 3 times 2 minus 1, which gives you 1 times 1. And my vertex is 2, 1. So that means I would reflect my y-intercept over here. And again, I'm on the smartboard, my laptop. So this is not going to be God's gift to drawing with a laptop pad, but there's your parabola. Finishing the rest of the work, I know that my domain is all real numbers. My range is all of the y values less than 1. I know that this opens down not just by the graph, but because the coefficient on my y equals negative x squared plus 4x minus 3 is negative, so that opens down. Because that coefficient is 1, I do not have a vertical stretch or a shrink. And I do have a maximum value at the vertex 2, 1. And here's our last example. This is another example of a quadratic equation in standard form that we have to graph. Unfortunately, you aren't given the vertex, you aren't outright given the x-intercepts, and this is not an example that can factor into intercept form. So what do we do? Well, one thing that is easy to calculate is the y-intercept. It's 2, because if you just put 0 in for x, 0 squared minus 4 times 0 plus 2 equals 2. So it's simply the constant. So I know that the y-intercept is 2, and let's go ahead and plot that. We'll plot its mirror later. Now I do know that the domain is going to be all real numbers. Because the coefficient on the quadratic term is 1, I know that opens up, and that I do not have any kind of vertical stretch or shrink. So where do I go from here? Well, we're going to take this equation, y equals x squared minus 4x plus 2, and we're going to do quadratic formula on it. So we have x equals the opposite of negative 4, which is 4, plus or minus the square root of negative 4 squared, which is 16, minus 4 times 1 times 2, all over 2 times 1. Yeah, I'm sorry, that was probably pretty excruciating. But you lived through it. So what is 16 minus 4 times 1 times 2? That's 8. Root 8 breaks down into 2 root 2. And then that simplifies into 2 plus or minus root 2. So my x-intercepts are 2 plus or minus root 2, 0. Yes, you could write those as two separate coordinates, 2 plus root 2, comma 0, and 2 minus root 2 over a comma 0. What I do not want you to do, oops, I did the wrong thing there, is I don't want a decimal approximation. I want an exact answer. Here's why you want an exact answer. If I know that my x-intercept is 2 plus or minus root 2, ask yourself what that means. If I locate where x is equal to 2, now I want to make this clear. This is not, I'm doing this in green because this is not a point on the parabola. This is simply where x is equal to 2. But if you think about what this means, I need to take 2 plus or minus root 2. Well, root 2 falls in between root 1 and root 4. So that means root 2 has to be in between 1 and 2. So when I plot the x-intercepts, I start at 2, and then I go not 1 and then a little bit more of a box to the right. And then I start at 2 and I go 1 and a little bit more of a box to the left. So doesn't that mean that 2 has to be in the middle? So if you understand your answer, that part of quadratic formula, the part that you get, that opposite of b over 2a portion, that is your axis of symmetry. So my axis of symmetry is x is equal to 2. And then that's also the y-coordinate of my vertex, excuse me, the x-coordinate of my vertex. So here is the work to find the y-coordinate of my vertex. I put in 2 squared minus 4 times 2 plus 2, which is 4 minus 8 plus 2, which yields a negative 2. So I'm going to go ahead and plot the vertex here. I am going to reflect my y-coordinate. And there you go, my friends. Again, another probably poor drawing. A little bit better. There is an example of my parabola. So now I know that my range are going to be all the values greater than or equal to negative 2, and that I have a minimum point at 2, negative 2. And before I sign off, I wanted to review that sometimes when you don't know how to do something, you might want to turn it into a different form, and that might be helpful for you. So as a reminder, let's say that you were given an equation that was in vertex form and you want to put it in standard form. What do? Well, you could rewrite it as y equals negative x plus 1 minus 6, and you could distribute to put that into standard form. Okay. What if you have standard form and you want to put it in intercept form? And that was kind of like the first standard form example we did. You factor. What if you have intercept form and you want to go to standard form? You distribute first, outer, inner, last. And last but not least, if you are in standard form and you want to go to vertex form, then you would complete the square to put it in vertex form. Your assignment is this following learning opportunity. Page 270 is where it starts. Do problems 1 through 8 and 11. On 13 to 27 odd, make sure you find all the information we did in class. If you use the graph paper I gave you, it should be a non-issue. 37 to 49 require you to work backward. It's a little bit of a different problem, but you can do it. 78, 79, 83, and 85. And don't worry about 88. You can use GeoGebra or your graphing calculator, but that could be something we go over in class. But see if you can tackle it yourself. Good luck.